Good morning, sir. My name is Sujan from second year electrical department. Today I am going to discuss about that BJT biasing concept, viewpoint and load line. My introduction is here. First of all, introduction to BJT biasing. Biasing a dipolar junction transistor is the process of setting the internal operating point, known as Q point, to ensure the transistor function properly. Proper biasing is crucial for optimizing the transistor's performance and behavior in electronic circuit. So once there are circuit. Importance of BJT biasing. So first of all, clarity, two, second, stability, three, efficiency. Clarity. Biasing a BJT ensures it operates in the planar region, enabling planar application of signal. Stability. Proper biasing helps maintain the Q point despite variance in temperature, power supply, or other factors. Efficiency: biasing optimizes the transistor power consumption and heat dissipation, improving overall circuit efficiency. Concept of Q point. Q point definition. The Q point or quiescent point is the initial operating point of a BJT, defined by the controller current and collector emitter voltage. Importance of Q point. The Q point determines the transistor operating region and is critical for ensure linear amplification stability and efficiency. Location. The Q point. The Q point is defined on the transistor output characteristic curve, which shows the relationship between IC and VCE. Factors affecting on Q point. So there are few factors affecting on Q point: bias resistor, power supply, and temperature. Bias resistor: the value of bias and collector bias resistor directly impact the Q point location. Power supply: changing in the power supply voltage can shift the Q point, affecting the transistor's performance. Temperature: variation in temperature can cause the Q point to dark, requiring compaction. Significance of Q point. Amplifier operation. There are two significant of Q point: amplification operator, distortion or reduction, efficient operation, stability and reliability. Amplifier operation: the Q point determines the transistor operating region, which is crucial for linear amplification of signal. Distortion reduction: proper biasing minimizes signal distortion by keeping the transistor in linear region. Efficient operation: the Q point affects the transistor power consumption and heat dissipation, impacting overall circuit efficiency. Stability and reliability: a stable Q point helps maintain consistent transistor performance over time and under various conditions. Understanding load line. Load line definition. Load line is a graphical representation of the uh, relationship between collector current and collector emitter voltage of a BJT. Determine load line. Load line is a constructed based on circuit load resistor and power supply voltage, and it interacts the transistor output characteristic curve at the Q point. Significance of load line. The load line helps visualize the transistor operating region and is crucial for properly biasing the BJT. Constructing load line. So there are two steps to construct load line. Step 1, identify the power supply voltage and load resistor values. Step 2, calculate the point on the load line using the equation VCC VCE equal to VCC minus IC into RL and IC equal to VCC by RL. Step 3, plot the two point on transistor output characteristic curve to construct the load line. Relationship between Q point and load line. Q point on load line. Q point is the intersection of the transistor output characteristic curve and load line, which determines the initial operating point. Importance of alignment. Proper arrangement of Q point and load line is crucial for ensuring linear amplification, stability, and efficiency operation of BJT. Impact of misalignment. If Q point is not properly aligned with a load line, transistor may operate in one linear region, leading to distortion and instability. Importance of proper biasing. So there are few importance of proper biasing. Linear amplification, stability, and efficiency. Linear amplification. Proper biasing enables the transistor to operate in linear region, allowing for linear amplification of signal. Stability. Biasing the transistor at current Q point helps maintain stable and con- consistent consistent performance over time and under various conditions. Efficiency. Approximate appreciate biasing optimize the transistor power consumption and heat dissipation, leading to improved overall circuit efficiency. So there are conclusion and key takeaways. Biasing importance. Proper biasing of BJT is crucial for ensuring linear amplification, stability, and efficient operation of the transistor. Q significance. The Q point or Q point defines the initial operating point of the transistor and must be carefully selected. Load line relationship. The load line and Q point must be properly aligned to optimize the transistor's performance and behavior. Comprehensive understanding. A deep understanding of BJT biasing, the Q point and load line concept is essential for effective resistance circuit design. There are two picture PN junction and PN junction and NPN junction. So last difference book other source ChatGPT AI etc. Thank you.